The sun beats down on the Tethys coastline, but the real drama is unfolding where the turquoise waves meet the muddy, silt-heavy mouth of a prehistoric river. This is the deadly divide, the invisible wall that has kept the titans of the deep and the giants of the shore in their respective lanes for eons. To us, water is water. To a marine reptile, crossing from the ocean into a river is like a human trying to breathe in a room filled with smoke. Imagine you are a juvenile polycotylid. You are built for the open blue, sleek, powered by 4 rhythmic flippers, and evolved to slice through high-density brine. But today, the shoals of fish you've been chasing are darting inland, disappearing into the murky, tea-colored discharge of a massive delta. You hesitate. Every instinct in your prehistoric brain screams a warning. The first challenge is invisible: osmoregulation. In the ocean, your body is a fortress designed to keep salt out and water in. Your cells are bathed in a delicate balance. The moment you cross that invisible line into freshwater, the physics of life flip upside down. Without the high salt content of the sea, the river water tries to flood your tissues through osmosis. To stay here is to risk your very cells swelling and bursting. It is a chemical battleground. Then there is the light. In the open sea, you can see for 100 feet. In the river, the water is thick with the debris of a continent, decaying ferns, pulverized silt, and the runoff of monsoon rains. Your eyes, evolved for the crystalline blue, are suddenly useless. You are hunting in a fog. You must rely on the pressure sensors in your jaw, feeling the heartbeat of a fish before you ever see its scales. But why make the leap? Why leave the majestic safety of the reef for this claustrophobic, muddy maze? The answer is the same then as it is now: opportunity and fear. The Cretaceous oceans were a who's who of nightmares. If you stayed in the deep, you were prey for the 15-meter Mosasaurs that patrolled the shelf like living torpedoes. The river, despite its chemical hostility, offered a sanctuary. It was a nursery, a hidden larder filled with slow-moving lungfish and oversized crustaceans that had never seen a predator with your speed. As you push further upstream, the sound of the crashing surf fades, replaced by the heavy, humid silence of the swamp. The water grows warmer, shallower. You feel the drag of the river current, a constant, exhausting force you never had to fight in the tidal currents of the bay. Your flippers, designed for the effortless glide of the abyss, must now labor against the downstream push of a continent's drainage. This is the transition point that changed the course of evolutionary history. It wasn't just a physical move, it was a biological revolution. The creatures that survived this deadly divide were the pioneers of a new kind of terror. They were the ones who learned to tolerate the fresh water, who adapted to the low visibility, and who realized that in the narrow confines of a river, an apex predator doesn't need to be the biggest, it just needs to be the most patient. The deadly divide was the ultimate filter. Thousands of marine scouts likely died on these banks, their systems failing in the low salinity soup. But for the few who endured, the reward was an entire world of untapped prey. The sea monsters were gone. The era of the river monster had begun. The heavy, humid air of the early Cretaceous hangs still over the meandering river systems of what would one day be the Australian outback. But today, this is not a desert. It is a labyrinth of winding freshwater channels snaking through lush forests of ginkgo and conifers. The water here is cool, stained dark by tannins from fallen timber, and seemingly peaceful. But beneath the surface of these inland arteries, a shadow is moving, a shadow that belongs in the deep, crushing pressures of the open ocean, yet is now cruising through the heart of the forest.
This is the era of the Pliosaur, the Inland Invader. To understand the Pliosaur is to understand a biological powerhouse. Unlike their long-necked cousins, the elasmosaurs, pliosaurs were the heavy hitters. They were built like massive hydrodynamic battering rams, with short necks and enormous skulls, some reaching nearly 2 meters in length. They possessed a bite force that would make a Tyrannosaurus rex take a step back. Usually, these were the lords of the high seas, patrolling the blue for anything they could fit in their jagged, interlocking teeth. But the fossil record tells us a stranger story. Some species, like the Mosasaur and the Leptocladus, decided the ocean was not enough. Imagine standing on a riverbank 120 million years ago. The water is only 5 or 6 meters deep. You might expect to see primitive crocodiles or perhaps large fish. Instead, a massive, pale shape glides silently past your feet. It is a pliosaur, adapted for life in the shallows. These weren't just accidental tourists, they were specialists. To thrive here, they had to evolve. Their bodies became more compact, their flippers slightly modified to maneuver in tight river bends where a 10-meter body would otherwise become grounded on a sandbar. The invasion was driven by a brutal calculation of survival. In the open ocean, life was a constant war of attrition, but the rivers were a treasure trove. Huge schools of ancient ray-finned fish and freshwater mollusks provided an easy feast. However, the pliosaurs weren't just here to eat, they were here to hide. The inland invaders likely used these murky channels as a refuge. In the rivers, their young were safe from the truly gargantuan predators of the deep sea. The dark, sediment-heavy water provided the perfect camouflage for an ambush predator. But life as an invader was a high-stakes gamble. The fossilized remains of these creatures found in freshwater deposits show us the toll this lifestyle took. They had to endure extreme seasonal shifts, fluctuating water levels that could leave a massive marine reptile stranded in a shrinking pool during the dry season, and freezing temperatures in the high-latitude rivers of Gondwana. Some scientists believe these river specialist pliosaurs may have even developed higher metabolic rates to cope with the cold inland winters, a far cry from the stable temperatures of the tropical Tethys Sea. As you listen to the sounds of this ancient river, the splash of a lungfish, the call of a primitive bird, remember that the ripple you see in the center of the stream is not a log. It is a cold-blooded killer that has traveled hundreds of miles from its saltwater home. The pliosaurs proved that the boundary between world ecosystems was porous. They redefined what it meant to be a freshwater predator, turning quiet rivers into extensions of the deadly prehistoric sea. They were the first to prove that no matter how far you went inland, the monsters of the deep could still find you.
If Carcharodontosaurus was the perfection of the traditional dinosaur, Spinosaurus aegyptiacus was the ultimate subversion of it. For nearly a century, we pictured Spinosaurus as a sort of Godzilla light, a T-Rex with a sail and a long face. But in the last decade, a series of revolutionary discoveries, spearheaded by Dr. Nizar Ibrahim and his team, has completely torn down that image. What emerged from the dust of the Moroccan Sahara was not just a new dinosaur, but a new kind of animal altogether, the river monster. This is the chapter where the Spinosaurus is redefined. Imagine a creature that breaks all the rules. Stretching up to 50 feet in length, it was longer than a T-Rex and heavier than an elephant, yet its skeleton tells the story of a life lived almost entirely in the water. The first thing you notice is the skull. It is narrow, elongated, and tipped with a sensory array of small pits. These are neurovascular openings, identical to those found in modern crocodiles. They allowed Spinosaurus to sense the pressure waves of swimming prey in pitch black or murky water, effectively giving it biological sonar.
Its teeth were not the slicing blades of its rival Carcharodontosaurus. Instead, they were straight, conical, and smooth, perfectly evolved harpoons. They weren't meant to cut, they were meant to grip. Once those jaws snapped shut on a slippery 6-foot-long lungfish or a prehistoric sawfish, there was no escape. This was a specialist fisher, an apex predator of the river channels that had more in common with a great white shark or a gharial than it did with any land-dwelling dinosaur. But the most shocking redefinition came from the tail. For decades, we drew Spinosaurus with a stiff, tapering tail like other theropods. Then, in a landmark 2020 study, fossils revealed a broad, paddle-like structure with tall neural spines. It was a fin. This massive, flexible tail would have allowed Spinosaurus to propel itself through the water with powerful lateral strokes. It didn't just wade, it swam. It was the first true semi-aquatic dinosaur known to science. And then there's the sail, that 6-foot-tall structure of bone and skin that rose from its back. Its purpose is still debated. Was it a thermal regulator to cool the beast in the African sun? Was it a billboard for mating, or a way to look even more massive to a rival Carcharodontosaurus? Whatever its function, it served as a terrifying dorsal fin, cutting through the river surface as the giant lurked beneath. The Spinosaurus was a master of the in-between. Its bones were dense and heavy, acting like a diver's weight belt to help it stay submerged. Its hind legs were unexpectedly short, suggesting that while it was a powerhouse in the water, it was likely awkward and slow on land, perhaps even moving on all fours or sliding on its belly. This redefinition changes the entire dynamic of our rivalry. Spinosaurus wasn't trying to be the king of the land. It had claimed a different kingdom, the deep, dangerous waterways of the Kem-Kem. It was a dragon of the delta, a 15-ton leviathan that could disappear beneath the surface with barely a ripple. But in an ecosystem this crowded, even a river monster has to come ashore eventually. And that is where the paths of the slicer and the gripper, the land king and the river king, began to cross.
In the high-stakes game of the Mesozoic, survival wasn't just about who had the biggest teeth, it was about who could handle the invisible burn. To understand the chapter we call Survival of the Swiftest, you have to look past the scales and the muscle and look into the very blood of the monsters. Moving from the ocean to a river isn't just a change of scenery, it is a physiological crisis. Think of a marine reptile's body as a high-pressure machine calibrated for salt. In the ocean, the water around you is saltier than the fluid inside your cells. The environment is constantly trying to suck the hydration right out of your skin. To survive, you evolved salt glands, biological desalinators, to pump excess minerals out of your eyes or nose. But the moment you swim into a freshwater delta, the physics of life flip. Now the environment is less salty than your blood. Instead of the water leaving you, it begins to force its way in. It floods your system, threatening to dilute your minerals and swell your cells until they fail. This was the first great filter. The swiftest weren't just the fastest swimmers, they were the ones whose internal chemistry could pivot the fastest. The survivors were those who could effectively shut off their salt glands and find ways to flush out the excess fresh water without losing vital nutrients. It was a metabolic tightrope walk. But the adaptation didn't stop at chemistry. In the vast open ocean, you hunt using long-distance vision and high-speed endurance. You are a marathon runner in a blue desert. But the river is a cluttered, tangled obstacle course. The water is choked with sediment, fallen logs, and thick vegetation. To thrive here, the swiftest had to undergo a structural revolution. Look at the flippers of the freshwater specialists like the polycotylids. In the open sea, long, slender flippers act like the wings of a glider, perfect for energy-efficient cruising. But in a narrow river bend, those long wings are a liability. They hit rocks, they get tangled, and they are too slow to turn.
The river monsters evolved shorter, broader, and more powerful paddles. They traded the long-distance glide for explosive stop-and-start acceleration. They became the dragsters of the muddy shallows. And then there is the sense of touch. In the murky gloom of a prehistoric river, being swift means reacting before you even see your prey. We see evidence in the fossilized snouts of these invaders, tiny pits and canals that housed a sophisticated network of pressure sensors. These animals could feel the vibrations of a lungfish's tail from dozens of meters away through the silt. They didn't need to see. They lived in a world of tactile echoes. This chapter of our story is about the incredible plasticity of life. It shows us that the giants of the Mesozoic weren't just rigid relics, they were dynamic. The survival of the swiftest was a race against extinction and a race against the very chemistry of the planet. The winners of this race were rewarded with a world free of the ocean's biggest terrors, but the price of admission was a total biological overhaul. They had to become leaner, more sensitive, and chemically versatile. They had to transform from oceanic gliders into river-dwelling ninjas. As the Cretaceous progressed, these adaptations became so refined that some species became obligate freshwater dwellers, losing the ability to return to the sea entirely. They had crossed the divide, and in doing so, they had rewritten the rules of what a sea monster could be.
The ripples have long since settled over the graves of the Mosasaurs and Pliosaurs, but the story of the leap did not end with the Great Extinction. As we move into the final chapter, the river monster legacy, we realize that the prehistoric drama of the deadly divide set a blueprint for life that still exists in our rivers today. Nature, it seems, is fond of a recurring character. When we look at the murky waters of the Amazon, the Ganges, or the Mississippi, we are seeing the modern echoes of that ancient Mesozoic ambition. The giants are smaller now, but the spirit of the invasion remains. Take, for example, the bull shark. It is perhaps the truest heir to the Mosasaur's throne. While most sharks are locked into a saltwater existence, the bull shark has mastered the same physiological switch we saw millions of years ago. They have been found thousands of miles up the Amazon and even in the landlocked rivers of the American Midwest. They are the living proof that the boundary between sea and river is still a frontier waiting to be conquered by those with the right internal chemistry. But the legacy goes deeper than just sharks. Think of the river dolphins of the Yangtze or the Indus. Millions of years ago, their ancestors were sleek oceanic hunters, members of the same lineage as the orca and the bottlenose. Like the polycotylids of the Cretaceous, they found the competition in the open ocean too fierce and the bounty of the rivers too tempting. They made the leap, and over time their bodies warped to fit their new home. Their eyes grew small and nearly useless in the silt, replaced by some of the most sophisticated sonar on the planet. Their flippers became broad and flexible, allowing them to navigate submerged forests, just like the Inland Invaders of the Jurassic. The legacy also lives on in the saltwater crocodile. Despite its name, this titan is a master of both worlds, using the river systems as highways to move between hunting grounds. It reminds us that the river monster is not a specific species, but a role, a niche that nature demands be filled. Whenever an ecosystem provides a surplus of food in the shallows, a monster from the deep will eventually evolve to claim it. This legacy teaches us that evolution is not a one-way street. The transition from sea to river was a testament to the resilience of life. It showed that the most successful creatures aren't always the ones who stay in their lane, but the ones who dare to cross the deadly divide and reinvent themselves. The Pliosaurs and Mosasaurs are gone, but they left behind a map of survival.
Today, when we hear stories of monsters in the dark reaches of our great rivers, we aren't just hearing tall tales. We are hearing the echoes of a 100-million-year-old tradition. The ancient sea monsters didn't just disappear. They transformed, they adapted, and they passed the torch to the predators of our modern world. The river remains a place of mystery and danger, a place where the rules of the ocean and the rules of the land collide. As you look out over a quiet river at sunset, remember the inland invaders. Remember the chemistry, the struggle, and the incredible journey from the abyss to the estuary. The monsters may have changed their shapes, but the river still remembers the weight of their shadows.